All right. Hi, guys. So this objective is about using midpoint and something called the segment addition postulate to find and represent segment lengths. Okay, so we'll start with our important vocabulary. So first, a point is just a dot in space, essentially. We'll be using segments. A segment is a straight path between two end points. So like, let's say A and B. We use segment notation to describe segments. So this is like the code to say segment AB, this symbol at the top. Just a little line without arrows, and then the two endpoints. You'll see the word expression a lot. An expression is just something like this. It's a quantity with a variable in it. Whereas an equation is when we set that expression equal to something. And then congruent means same size and shape. And then the symbol we use is like this little squiggle on top of an equal sign. That this symbol means congruent. Okay, so we're going to get right into it. So we did this activity in class. And in our key points box, we learned something called the segment addition postulate. That is when you see a picture like this. If we have point C lying on AB, so we have this entire segment A to B that I'll outline in orange. That distance is an orange distance. That entire segment AB is equal to basically AC is part of the segment. I go from A to C. Plus CB, from C to B. Right? If I combine the length of AC plus the length of CB, that is equal to the length of A to B. The blue plus the pink is the same as the total orange segment, okay? Now, that helps me answer a question like this. So if I want the length of AB, I want to know how long it is from A to B. Well, I'm noticing B lies between A and C. So AC is equal to the length of AB plus the length of BC. AB plus BC gives me AC, the whole thing. So I know AC is 9. It's labeled there. That's equal to AB. I don't know what AB is, so let's call it X, plus whatever BC is, which is 5. So a little equation forms where I can then solve and be like, oh, this part has to be 4, which makes sense because 4 plus 5 gets me 9. So that's me using the segment addition postulate to find a missing length, okay? Now, in some cases, on the next page, what if the point, we have a segment, and the point in between is in the middle? That might change our problem solving around how we can find segment length. That's called if we're dealing with a midpoint. A midpoint is a halfway point that divides the segment into two congruent, so same parts. Okay, so if I read M is the midpoint of AB, and it wants how long is segment AB if MB is 12? Well, if MB is 12 and M is in the middle, that means AM is also going to be 12. So how long is AB? Well, segment addition postulate, AM plus MB, I can do 12 plus 12 and get 24 for that total segment. Another way I can know if I'm looking at a midpoint is if I see congruency marks. So you can use congruency marks, which look like tick marks, to show when segments are congruent. So when I say tick marks, I mean like this. They're just like a little dash. You might have to see 1 dash, 2 dashes, 1 dash and 1 dash, 3 dash and 3 dash. That means that the segments are congruent. I can say that PQ is now congruent to QR if I see those markings. So in this picture, I see those markings. So that means B is in the middle. If those markings aren't there, I don't get to know that. Okay? And this says if AC is 32 and I find the length of AB, well, AC is 32. So how do I find AB, half of it? Well, 32 divided by 2 is 16. So each of these has to be 16. So AB is 16. Okay? So that was us finding segment length using the segment addition postulate or using if we have a midpoint. In our next key points box, so if we jump to page 3, we're going to start using algebra to find or express segment lengths. So sometimes we might use an expression to represent the length. The expression is when we use variables to represent the quantity. Okay, so if I see example 4 like this, it says points C, J, and T are all on segment CT. So I'm immediately going to start drawing a picture of that. So I see CT. Okay, and then J is somewhere in between. It says CT is 2x minus 4, 2x squared minus 4. And C to J is negative 3x squared plus 2x minus 7. What simplified expression can be used to represent JT? So what simplified expression? So the minute I read expression, I'm thinking variables. Okay? So what can I do here? Well, I know segment addition postulate says CJ plus JT can equal CT. I want JT, right? So how do I do that? Well, if I want just JT by itself, I would subtract. I would cut away. If I cut away CJ from say CT, see I'm like covering it, I'm cutting it away, I'm left with JT. Or kind of a thing of like an equation. So basically, I need to do CT, which is 2x squared minus 4, minus CJ, which is negative 3x squared plus 2x minus 7. And then I'm going to simplify my thing. So here, I'm going to do some color coding to help yourself see that. CT is this big expression here, right? The whole length. It's right there, right? If I take away from the pink length, the orange length, which is JT, or sorry, CJ, which is this length, right? I'm going to be left with, so think pink, take away, like cut away orange, I'm going to be left with whatever JT is. Okay? So, now I'm going to simplify this expression. First thing I have to do is distribute my negative sign. So, negative and a negative makes a positive 3x squared that. Negative and a positive makes a negative there. Negative and a negative makes a positive. Bring down my 2x squared minus 4. And then I'm going to combine like terms if I can. 2x squared and 3x squared is a total of 5x squared. Negative 2x doesn't have anything to combine with, but negative 4 and positive 7, that's a plus 3. Okay? So, JT can be expressed by that statement. Okay? And that's if we're expressing stuff. Let's look at example 5. What if we want the length of segment NP, looking at this picture here. So now I read the word length of NP. Now, length means we're going to use a number to represent the quantity. All right, so I'm looking at this picture and noticing N is in between M and P. So MN plus NP has to equal MP. So, and then I'm noticing like variables here, right? Like I want NP, but NP is described as 2 times whatever X is plus 5, and there's an X here. So what I'm noticing is if I substitute in these expressions into this setup, I'm going to get an equation that I can solve. So MN is X plus NP is 2X plus 5. These two quantities added should equal 32. And look, I see an equation form. So to find segment length, you're going to set up and solve an equation that represents the figure. Right? And this equation is the equation that represents the figure because this equation follows the segment addition postulate. Okay, so now I'm just going to solve this equation. X plus X is 3X plus 5 equals 32. Subtract 5, you're going to get 3X equals 27. Divide by 3, and you're going to get X equals 9. And you're going to tend to be like, I'm done. I'm done. But you have to find the length of NP. Well, NP is equal to 2 times whatever X is, 9 plus 5. So notice, X was 9. There's a 9 there. There's an X there, so I'm plugging in 9. I'm substituting. So first step after I set up and solved my equation that represents the figure, I'm substituting the variable value into the expression that represents the length. Now I'm just going to do this math. 2 times 9 is 18 plus 5. We get NP equals 23. Okay? And that makes sense because, hey, if this length is 23 and M is the length of X, which is 9, 9 plus 23 is 32. Okay. Okay. Now, let's look at example 6 quick. Example 6 says find PQ. As an expression first in terms of X. So as an expression in terms of X, well, PQ is equal to PM plus MQ. PM is 2X plus 8. MQ is 5X minus 4. So I'm just grabbing the expressions that are labeled with the segments. And then PQ is like if I just add them up. So I'm just going to combine them. 5X plus 2X is 7X plus 4. Hi, I'm in the middle of, I need a second. Sorry. Can you come back in 3 minutes? Can you come back in 3 minutes? I'm in the middle of filming a video that I can't pause. Okay? Thanks. Sorry. So my expression is going to be 7X plus 4. Okay? So that's how I could express the length of PQ if both of its parts are labeled as, if like part of the segment PM is 2X plus 8, plus the other part, 5X minus 4. Okay, so I just like took these two parts and added them together because the combo of the pink plus the orange is the whole segment, okay? Now, if I want the numerical length, this one said expression, so that's why I just did that. Now, the numerical length is like, okay, let me set up and solve an equation. So I already kind of did that here, but we don't know the length of PQ, so I can't solve. But I am noticing, oh man, tick marks. Tick marks mean that PM is going to be congruent to MQ. So then that means my 2X plus 8 is going to be equal to my 5X minus 4. These two quantities have to be equal if I want the segment lengths to be the same. So here is my setup of my equation then. I can do, and then I'm just going to solve. I'm subtracting 2 from both sides. I'm getting, 8 equals 3X minus 4. Add 4, add 4. I'm getting 12 equals 3X. This is me just really quickly solving. And then dividing by 3, X equals 4. Now, you might be tempted again to be like, I'm done. You're not. It asks for PQ. Okay? It asks for PQ, so I have to substitute. I have to go back to the substituting the variable value into the expression that represents the length that I want. Well, I want PQ, which is going to be equal to 2 times 4 plus 8. That's my pink part, right? Plus MQ is 5 times 4 minus 4. Okay, that's my orange part. Okay, guys, I just need 2 minutes to finish this, okay? All right, so 2 times 4 is what? 8 plus 8, and you get 16, plus 5 times 4 is 20, minus 4 is again 16. And hey, that makes sense. It makes sense that for the pink segment, I get 16, and for the orange segment, I also get 16 because they should be the same. 16 plus 16 is 32 for the whole segment length. So my answer there is 32. Okay? Last question, real quick. So it says, example 7, if PQ is 18 inches long, find X. So looking at this picture, again, I'm noticing tick marks. So what I want to notice here is, and the whole thing is 18, okay? So I'm like, okay, it wants X, so let me set up and solve an equation for X. If you guys are Mr. Government, guys, you can take a seat. I just need 2 minutes to finish this, okay? Sorry, I can't pause this once I start. So just have a seat. Give me like 1 minute to be done. Part of the segment is 3X. The whole segment is 18, right? So you might be tempted to be like, well, 3X equals 18. But that won't follow PM plus MQ equaling PQ, will it? Right? Because 3X plus 18 is the whole thing. So you need something there. Well, these two are the same, so I'm allowed to put another 3X there. I'm allowed to say 3X and 3X. Okay, so I can put in another 3X here. So 3x and 3x is 6x equals 18. Divide by 6, divide by 6. You're going to get x equals 3. Okay? Oops, sorry. Another equation I could set up is, listen, if this is 18, 9 and 9, both of these would be 9 and 9. So I could say 18 equals, 3x equals 9. And get x equals 3. That's my answer there. Okay? So, a lot of math happened. In this lesson and in geometry, it's a lot of problem solving. We're practicing building equations and using algebra to find segment lengths. So some thoughts you can have here are if segments are congruent to each other, you see those ticks, you see the thing I did in blue, right? You can set their expressions equal to each other. That's what we did in this example. I was like, oh, these segments are the same, so I can say that 2x plus 8 equals 5x minus 4. Or, like I did in example 7, is you can use the same expression to represent both segments. That's why I was allowed to put another 3x here to help me solve. Okay, hope that made sense. I know it was so much math. This penguin wants to send you love and light.